In the following video demonstration, we'll explore DataHub's data catalog capabilities to collect, organize, enrich, and search for metadata across multiple platforms. I'm Gary Stafford, AWS Area Principal Solutions Architect and a member of AWS's Analytics Technical Field Community. You can find me on LinkedIn, GitHub, Medium, Twitter, and YouTube at Gary Stafford. This video represents my viewpoints and not those of my employer, Amazon Web Services, AWS. This video demonstration is based on a blog post, End-to-End Data Discovery, Observability, and Governance on AWS with LinkedIn's open source DataHub. It can be found at the tiny URL shown here. You can git clone the source code for this demonstration on GitHub. The name of the project in my GitHub repository is DataHub on AWS Demo. Agenda. First, we'll discuss what a data catalog is. Then, I'll briefly introduce DataHub. Next, I'll cover the high-level architecture used in this demonstration. And lastly, we'll spend the majority of our time in an actual hands-on demonstration, which closely mirrors the contents of the blog post. What is a data lake? Here are two of my favorite definitions, one from Oracle and one from Alation. First, from Oracle. A data catalog is an organized inventory of data assets in the organization. It uses metadata to help organizations manage their data. It also helps data professionals collect, organize, access, and enrich metadata to support data discovery and governance. Next, from Alation. What is a data catalog? A collection of metadata combined with data management and search tools that helps analysts and other data users find the data that they need, serves as an inventory of available data, and provides information to evaluate the fitness of data for intended uses. What are some of the features of common data catalogs? Some of those features include metadata ingestion, data discovery, data governance, data observability, data lineage, data dictionaries, data classification, usage statistics, sensitive data handling or obfuscation of data, data fitness, also called data quality or data profiling, metadata management, a business glossary, tagging and labeling, natively supported data sources, advanced metadata search capabilities, fine-grained authorization and authentication, and finally, both UI and API-based access. What are some of the leading data catalogs? I've broken them down into three different categories: open source, commercial or commercial open source, and cloud service providers. Under open source, we have LinkedIn's DataHub, Lyft's Amundsen, WeWork's Marquez, and Apache Atlas. Commercial and commercial open source offerings include Acroldata, Atlan, Stemma, Talend, Alation, Calibra, and Data.World. Cloud service providers include Google, Microsoft, and AWS. There's an asterisk here. Some of the offerings from the cloud providers are simply Hive-compatible metastores and not truly fully featured data catalogs. You'll have to make your own decision when looking at the capabilities of these products and if they meet your needs or if you need a more fully featured data catalog. So what is DataHub? DataHub can be found at datahubproject.io. DataHub's tagline is the metadata platform for the modern data stack. DataHub was built by LinkedIn, Acroldata, and the DataHub community. Acroldata is the commercial open source provider of DataHub. According to their website, founded by the leaders who created projects like LinkedIn's DataHub and Airbnb's Data Portal, Acroldata provides a developer-friendly, modern data catalog built on top of a next-generation metadata platform that brings clarity to data in all enterprises. DataHub was open-sourced by LinkedIn in February 2020. Two definitions from DataHub's website help describe the project. DataHub's extensible metadata platform enables data discovery, data observability, and federated data governance that helps tame the complexities of your data ecosystem. A second definition. DataHub is a third-generation metadata platform that enables data discovery, collaboration, governance, and end-to-end observability that is built for the modern data stack. Let's talk a little bit about the architecture for the demonstration you're going to see today. Here's a high-level diagram from the original blog post showing one of the options for integrating DataHub into your AWS environment. For this demonstration, DataHub was installed onto an Amazon EKS or Elastic Kubernetes Service cluster using DataHub's Helm charts. DataHub provides Helm charts for deploying DataHub and its data storage dependencies, Elasticsearch, optionally Neo4j, MySQL, and Kafka on a Kubernetes cluster. You actually have two options for deploying DataHub storage layer dependencies. You can run the required storage dependencies as Kubernetes pods on the Kubernetes clusters using DataHub's Helm chart. You can also use AWS managed services for the storage layer. According to DataHub's documentation, managing the services like MySQL, Elasticsearch, and Kafka as Kubernetes pods require a great deal of maintenance. To reduce that workload, you can use managed AWS services like Amazon RDS for MySQL or Amazon Aurora for MySQL, Elasticsearch service, and manage Kafka or MSK as a storage layer for DataHub. The DataHub docs have a friendly install guide for AWS. Let me just flip over to that quick. They have a complete guide to installing DataHub on AWS using Elastic Kubernetes Service or Amazon EKS and their Helm charts. For this demonstration, I've used Amazon's Route 53, AWS's DNS service, along with AWS Certificate Manager or ACM to expose a secure subdomain to host the DataHub UI. The UI will be used to access DataHub's data catalog. It also provides an administrative interface in addition to the CLI utility to access DataHub's RESTful API. And that's one of the big advantages of DataHub. I don't have to log into my AWS console in order to access DataHub. As an admin or a user, I have direct access to DataHub through the DataHub web browser. Data sources that we are extracting or ingesting metadata from are referred to as sources with DataHub. DataHub currently has about 50 sources. Some of those are push-based, while others are pull-based ingestion. In this demonstration, we'll explore the following metadata sources on AWS. Amazon Relational Database Service, or Amazon RDS. I've set up 3 Amazon RDS databases for this demonstration. Amazon RDS for PostgreSQL, Amazon RDS for MySQL, and Amazon RDS for Microsoft SQL Server. Other sources include Amazon Aurora PostgreSQL, Amazon Redshift Serverless, the cloud data warehouse offering from AWS. I've created both a provisioned Amazon Redshift cluster as well as an Amazon Redshift Serverless endpoint, which is a new service offering from AWS. Other sources include Amazon Managed Streaming for Apache Kafka or Amazon MSK, AWS Glue Data Catalog, a Hive-compatible metastore, and Amazon Athena. In addition to the AWS services, we'll be exploring the following non-AWS metadata sources: dbt, Snowflake, MongoDB Atlas, and Google BigQuery. Not covered in this demonstration, but covered in the blog post, are an on-premise data center metadata source, like Microsoft SQL Server on-prem, Apache Spark, which on AWS could be either Amazon EMR, formerly known as Amazon Elastic MapReduce, and AWS Glue jobs. The last source that's not covered in this demonstration that was covered in the blog post is Apache Airflow. On AWS, that would be Amazon's managed workflow for Apache Airflow or Amazon MWAA. Lastly, although we could use the DataHub UI to configure our sources and ingest our data, I will be using DataHub's CLI. For increased security and for ease of networking, I've created a Python container within a Kubernetes pod and deployed it adjacent to DataHub on Amazon's EKS cluster. The container has all the necessary DataHub dependencies and tools that I'll use for the demo. All DataHub ingestion activities will be initiated from within the container on the Amazon EKS cluster adjacent to DataHub. For brevity, I've reduced the scope of the demonstration that was originally shown in the blog post. I've excluded the GitOps or DevOps aspects of the blog post. Instead of GitOps or GitHub Actions, we will interact directly with DataHub via the DataHub API and the UI. I will also use a Kubernetes-based DataHub storage dependencies versus using the AWS managed services that I described earlier. One last diagram and then we'll move on to our demonstration. Like its name, DataHub, DataHub is the hub in a hub and spoke model. In the demonstration, DataHub and the DataHub API sit in the center of the diagram in the EKS cluster within their own VPC. It is the hub, and each of the data sources are spokes from which data is pushed to or pulled from DataHub using the API or the UI. We'll now jump into our demonstration. So I'm in the AWS console, and we can see here that we have a single Amazon EKS cluster, EKS demo cluster. I've created a relatively small cluster. I'm running Kubernetes 1.24. I have 4 worker nodes associated with the cluster, so I have 4 M5 extra large worker nodes. You certainly don't need that many worker nodes or maybe even that size worker node. It is a relatively small cluster. I'm just running DataHub on this for the demonstration. They're running within a VPC. I have 4 subnets associated with the VPC, associated with the cluster, and we have our associated security groups. Let me show the deployments for a moment. We'll go over to resources, and we'll go over to deployments first. Let me switch back into DataHub. And we can see we have a total of 5 deployments. So if you recall, I mentioned the Helm charts. So Acral Data manages Helm charts. I've gone ahead and deployed those Helm charts. I've deployed the prerequisites. So I've deployed the pod-based storage backends, and we'll take a look at those in a moment. And when those were up and running, then I went ahead and deployed DataHub. So we can see we have the DataHub Acral Data actions, the API, the front end, the GMS, and the schema registry. So those are the 5 deployments. We can take a look at the pods also that are running. So within the DataHub namespace, I created a separate DataHub namespace in order to deploy everything. And we can see we have a total of 23 pods. Now, those aren't all running pods. Some of those are part of the setup job. Some of those failed. Some of those took a while to succeed. If I switch over to iTerm for a minute, I've logged into the AWS account in my iTerm console here, my terminal. And let me just bring up those pods. So again, I'm using the DataHub namespace. Let's just take a look at the running pods and we can get kind of a sense for what DataHub looks like running on Kubernetes. So these are all the running pods that are associated with DataHub. We can see we have the prerequisites. So we have Zookeeper running, we have Neo4j running, we have MySQL running, we have Kafka running, and we have Elasticsearch running. So those are all part of the prerequisites. We also have the schema registry. And then for DataHub, we have the GMS pod, the front end pod, and the actions pod. The second pod that's shown here, the DataHub API pod, is actually my pod. So in addition to DataHub running in this namespace, I mentioned earlier I created a separate Docker container. Within that Docker container, that Docker image, I installed all of the necessary DataHub utilities and tools that I needed, along with some additional tools. So within a single pod, I have that container running. We're going to log into that container. That container has the DataHub CLI running inside of it, has all the tools that I need, and all of my ingestion tasks are going to be done from that container. We're going to exec into that container on the EKS cluster and do our work later on. So all the containers you see here, except for the second one, are what you would expect to have up and running if you properly deployed DataHub to Amazon EKS, including the prerequisites. So again, I'm not using managed services, the AWS managed services for my storage backend. Since this is just a demonstration, I'm trying to keep the cost down if anyone wants to follow along with the demo. So I've gone ahead and deployed the prerequisite storage backends right on Kubernetes versus having those run as AWS managed services. Let me switch back to the console for a minute. So that's EKS, that's DataHub running on EKS. So how do we access the DataHub front end UI? I mentioned before during the demonstration that I stood up a Route 53 hosted domain, which I own. I configured an A record to redirect the traffic to a subdomain to the Elastic Load Balancer. So in front of this cluster, in front of the DataHub deployment, is an Elastic Load Balancer. And I have a domain which I own. I've registered that with Route 53. When traffic hits that domain in a particular subdomain, let's switch over to that for a moment. So you can see here I have an A record. So I own analytics-demo.com. I set an A record up for the subdomain of DataHub, so datahub.analytics-demo.com. Whenever traffic hits that subdomain, it's going to be routed using Route 53. The DNS will be rerouted to the Elastic Load Balancer that I have set up in front of my EKS cluster, in front of the DataHub deployment, and it's been routed directly to the front end pod. So if you remember here, we have the front end pod running. That's running on a particular port. In this case, I also have a TLS certificate. So I used AWS Certificate Manager to create a certificate for that domain and that subdomain, and I've applied that to the load balancer. The front end for DataHub, which I'm running on my EKS cluster, is accessed over HTTPS. And when you hit this on HTTPS on this address on port 443 or HTTPS, we'll end up hitting the front end of DataHub, and we should bring up the login to DataHub. Lastly, I've restricted all access to DataHub to only my IP address. So even though it is a public URL, datahub.analytics-demo.com running on port 443 or HTTPS, I've limited the access to only my IP address, so no one else should be able to access this except myself for the demonstration. And we can see that if I switch back over here, so switch over to the front end, so you can see here datahub.analytics-demo.com. I've already gone ahead and logged in as my user as Gary Stafford. You can see the different platforms that we're going to be seeing during the demo, how we ingest those into DataHub. You can see those all displayed here, but this is DataHub running. So this is running on Amazon EKS. I've used Route 53. I have my own domain registered. I've registered a TLS certificate to make sure that it's secure traffic to it. And I've also limited access to this URL from only my IP address using the security group. So it should be secure. Let's move on and talk about the data sources for a moment. Switching back over to the slide for a moment to the architectural diagram, again, RDS, Aurora, Redshift, Athena, MSK, and Glue, and then Snowflake, Mongo, BigQuery, and dbt. Let's take a look at RDS for a minute first. So you can see here I've switched over to the Amazon RDS console, and for this demo I've set up a couple databases. So again, we have the DataHub demo MS SQL database, so that's a SQL Server Express Edition 15.0 that I have running. I also have a MySQL Community Edition 5.7. We've also set up a PostgreSQL instance 14.5. And then for Aurora, I have a choice with Aurora of MySQL or PostgreSQL. I've set up an instance of Aurora running 14.5. So again, we have SQL Server, MySQL, PostgreSQL, and for PostgreSQL, I have both an Amazon RDS and an Amazon Aurora database. Next, we'll take a look at Redshift. Amazon Redshift is AWS's cloud data warehouse, and they now have two options. So we can have a provision cluster and we can have a serverless cluster, or a serverless endpoint to be more specific. I've set up a cluster. So we have a provision cluster here that we're going to be hitting as one of our data sources and ingesting the metadata from that cluster. And I also have a serverless endpoint set up. So I've set up what's referred to as a work group and a namespace, and we have an endpoint, and we're going to be hitting that data source and ingesting metadata from that. We're also going to be using dbt later, so the same database that I'm going to be ingesting data from directly from Redshift, we're also going to be hitting a dbt endpoint, or I should say dbt project, and that project is also pointing to this database, and we'll see the difference between how data looks ingesting it directly from Redshift versus from dbt. Next, we'll take a look at Amazon Athena. So we're going to be ingesting metadata from Amazon Athena. More specifically, we're going to be ingesting data from an AWS Glue data catalog or a Glue metastore, a Hive compatible metastore for a particular table. So I've created a sample database, a Hive compatible metastore database. That underlying data is stored in Amazon S3, and we're going to be ingesting the metadata from that catalog from a single table. I mentioned AWS Glue. We also have AWS Glue. So we're going to be ingesting data from a series of databases. Again, AWS Glue Data Catalog is a Hive compatible metastore. We can ingest that data into our data catalog. So we're going to be ingesting the metadata from a few different catalogs and a number of tables into DataHub. We can also ingest Glue jobs. So Glue jobs are based on Spark. And as part of cataloging AWS Glue in my account, we can also catalog the AWS Glue jobs, which are Spark jobs that run in some of the metadata information about that. Next, we have Amazon MSK or Managed Kafka. So I've set up a Kafka cluster running a total of 2 brokers. We're running Apache Kafka 3.31. I've gone ahead and created a few topics and set up a streaming sales generator. I've talked about that in a previous post. That streaming sales generator generates product information, sales information to a series of topics. So we're going to be able to ingest the metadata about the messages in those topics into DataHub. So those are all the data sources we're going to talk about and see how we ingest metadata from those data sources using DataHub. In addition to AWS, we can also ingest data sources from any other source that's available through DataHub. It doesn't need to be on AWS. Even though we're running DataHub on AWS, on Amazon EKS, we can ingest metadata from any data source on AWS or on any other platform. We're not limited to AWS. And that's, again, in my opinion, a huge advantage of DataHub. We're not limited to the cloud provider's services or the cloud provider's data sources. With DataHub, we can install that on Azure, we can install it on Google, we can install it on AWS in this case. We can ingest the data sources on that platform, but we can also ingest other data sources. We can ingest data sources from on-prem as long as we can connect to those securely and based on the networking. We can access and ingest metadata from other SaaS providers, and we can ingest data from other cloud service providers, which is what we're going to do today. So in addition to the AWS sources that we're going to ingest metadata from, I also have a Google BigQuery cloud data warehouse. So we're going to be looking at Amazon Redshift Cloud Data Warehouse, Google's BigQuery Cloud Data Warehouse, and also Snowflake Data Warehouse. So really the 3 leading cloud data warehouses, we're going to ingest data from all 3 of those into DataHub. So in my Google account, I have a BigQuery set up. I have 3 databases that we're going to be ingesting data from. I also have a Snowflake account that I set up, a demo account, and I've ingested some of the sample data into a cloud data warehouse. And we're going to ingest the metadata information about that database and the data in that database into DataHub. And lastly, we have MongoDB Atlas. So I've set up a MongoDB Atlas database. I've created a few collections based on their sample data. and we're going to be ingesting data from MongoDB Atlas into DataHub. So MongoDB Atlas is running on AWS. You could choose Azure or Google or AWS. I happen to choose AWS, so it's in a separate account. It's in MongoDB's account. We're going to be ingesting data from this SaaS provider into our own AWS account in a DataHub. Similar to Snowflake, I also set up Snowflake and chose AWS. So we'll be ingesting data from our Snowflake SaaS account into our AWS account on AWS. And then lastly, we have Google BigQuery. So I've set up BigQuery on Google Cloud, and we're going to be ingesting metadata information about a few databases that are running in BigQuery and bring that information into DataHub running on AWS. So those are all of our data sources. In the next part of the demonstration, I'll show you how to ingest data from these data sources. In the next part of the demonstration, we'll ingest metadata into DataHub. Let me start by showing you the GitHub project. I mentioned earlier there's a GitHub project associated with this video. All of the files that you'll need to follow along with the video demonstration are included in the GitHub project. Let me walk through the different files that are part of the GitHub project. In order to do that, I'm going to switch over to PyCharm, and I have the GitHub project cloned locally. And let's go through and see what files are in here. Starting off with the business glossary, there's a business glossary directory. And we're going to be talking about the business glossary a little bit later in the demonstration, but there's a business glossary included here, both the glossary and the file necessary to ingest that into DataHub. And again, we're going to cover the business glossary in a little while. We also have the DataHub CLI container. So we have the DataHub CLI resource file for Kubernetes. And what I've done is I've built a DataHub CLI Docker image, and I have the Docker file here. So if you want to build your own, I started with a base Python image. I've installed some of the utilities that I commonly use as I'm working with DataHub. I've installed the DataHub CLI 0.9.5, and then I've installed a number of plugins, and we'll talk about plugins in a minute. One thing that's important to note here, I'm installing a specific version of DataHub or the DataHub CLI. You want to make sure that the version of the DataHub CLI that you install is the same as the version of DataHub that you installed. So in this case, 0.95 is the version that I'm running of DataHub on Amazon EKS. So I want to make sure that I install the same DataHub CLI version so I don't get any errors or issues. So that's the Docker file. And again, this is the Kubernetes resource file. If you want to install that image, it's available on Docker Hub, or you can simply install the Python image and then build the image yourself using the commands that are found in the Docker file. Note that during the video, I sometimes refer to the Docker Hub CLI or the Docker Hub CLI container as a Docker Hub API. It's probably more accurate to refer to it as a Docker Hub CLI. Although it does talk to the API, I'm typically referring to the DataHub CLI when I mentioned API. We also have the ingestion folder, and this is where the bulk of the files are. Everyone tends to organize their files differently with DataHub, or specifically organize their recipes separately, and we'll talk about recipes also in a minute along with plugins. So I have a couple folders here. I tend to organize by cloud service provider. So I have AWS and GCP. If I had any assets on Azure, I would also have a Microsoft Azure folder. And then I have a folder for any on-prem data sources that I'm going to be ingesting from. And then I have a folder for all of my SaaS partners that I ingest data from. So in this case, dbt, MongoDB Atlas, and Snowflake will be ingesting metadata from those different resources. So I have those under SaaS providers. If we go into AWS for a moment, I further divide my cloud service provider by my account. So I have two accounts in here. And if we tip down the first account, I've further broken that down by region. Now, you may be able to reuse a recipe across multiple accounts or multiple regions. It depends on how many environment variables you inject into the recipe. And we'll talk about environment variables in a few minutes and how we use those. So you don't necessarily need a separate recipe for every single account, for every single region, for every single database, depending on your naming conventions, how you apply credentials, etc. But in this case, I've divided up AWS by my account and then by my regions. And all of the files for this demonstration are in AWS in the first account in US East 1. And then we also have files for GCP for BigQuery, and we have our SaaS providers. But for the AWS resources, you'll find all those under AWS under the first account 111, 222, etc. And I put those under US East 1. And we can see here we have a number of YAML files. These are all our recipes. We'll be talking about what recipes are in a little while. And there's also a few Python files. I'll also discuss the difference between the Python files and the YAML files and how you have a choice in which way you ingest your metadata using either one of those. So those are where you'll find all the files that we're going to be ingesting today in the ingestion folder. Lastly, there's a set of ingestion instructions. So most of the commands that I'm going to be running during the demonstration, you can also find in here. Shows you how to pip install the individual plugins if you want to build your own container. Shows you how to check for which plugins you have installed. And then it also shows all the environment variables that I'm going to be setting, and we're going to be doing that in the next part of the demonstration. But these are all the environment variables, and these environment variables are injected into our recipes or into our Python files. The Python files will also pick those up from the environment. But again, we'll be talking about that in a few minutes. And then I have all the DataHub ingest commands that we're going to be using in the next section. So you should be able to find all the commands you need in this ingestion instructions. Lastly, there's a Redshift schema comments. We're going to be talking about extending the metadata. In this case, in a Redshift database, I'm going to be applying additional metadata on the table level and on the column level. We'll be covering this a little bit later on in the demonstration also. So these are all the files that you'll find in the GitHub project. You can use any of those to follow along with the demonstration. I mentioned plugins and recipes. I'd like to talk about plugins next, so I'm going to switch over to the DataHub documentation for plugins, and we'll start discussing plugins next. So the first thing we need to talk about is plugins. So for each one of the data sources, Redshift, Athena, BigQuery, Databricks, EMR, you need to install a plugin, and we do that by using pip install. So we could pip install Acral DataHub Athena, pip install Acral DataHub BigQuery. Those are two of the data sources we're going to be using today. So for each one of the data sources, we pip install those plugins in addition to DataHub. And you saw that in the Docker file. So if I open the Docker file again, we can see here the last command. I did a pip install and I deployed all of the different plugins that I needed to my container that we're going to be using today. So again, for each type of data source, we need a plugin, and that's how we extend the capability of DataHub in order to natively understand that particular data source. So we talked a little bit about plugins. Now let's talk about recipes in regards to DataHub and ingesting metadata. I'll switch back over to PyCharm. This is our GitHub project. I'll go into ingestion, AWS, the first account, US East 1. So you see a number of files in here. There's a few Python files, but for the most part, these are YAML files. And the YAML files are our recipe. So let me open one of the recipes. So this is the Amazon RDS for MySQL or Microsoft MySQL, and it's for the ticket database. So for each one of the databases or each one of the data catalogs, I have a separate recipe. So you can see that I have two for Athena because we're going to be ingesting two metadata catalogs. I have a number of RDS ones, one for each data source. And then, for example, with Postgres, we may have more than one database that we're ingesting for Postgres, so I may have more than one recipe. But I've opened the MySQL Server recipe here for Amazon RDS, and you can see a few different sections. So we have the source, we have the type of source, in this case, MS SQL. We have a configuration section. The configuration section will change depending on the type of data source that we're ingesting and the type of credentials that it needs. We have a transform section, and then we have a sync section. So this is where we're sending the metadata. In this case, we're sending it to a DataHub REST endpoint. You'll also notice in this case, I have a environment variable in here. One of the capabilities of the recipes is variable expansion. So I can set environment variables within my environment, and then when I ingest the metadata, when we run this recipe, and I'll show you how to do that in a moment, it will expand all these variables. So I don't need to expose my credentials, in this case, my MS SQL username or password, the host and port where I'm hosting MS SQL. All of these can be set up as environment variables, and then I can inject those into my environment in a number of different ways. I could use Amazon Parameter Store, I could use Amazon's Secret Manager, or I could simply inject those into an environment using my DevOps tooling. So these will all be expanded when we run the recipe. Let me switch back over to iTerm, and I'm going to show you the DataHub CLI that we'll be using to ingest the data. I'm back in iTerm. I've logged into that pod. So I'm in the container within the pod, my DataHub API. So you remember before I showed you all the pods that were running in the DataHub namespace on EKS. I went ahead and inject into the DataHub API container within the pod. It's the only container running in that pod. I've installed the DataHub API. So this is, if you recall, the Docker file that we talked about. This container is a base Python image, so it has Python installed. I installed some utilities that we're going to be using today. I installed DataHub, and then I've installed all of the plugins that I needed. I've pip installed all of those plugins that I needed. Let me close that up. We'll switch back over to iTerm. So you can see here DataHub has a number of commands: check, delete, docker, git, ingest, etc. The first command, and the command that we're probably using the most today, is DataHub ingest. So we'll use DataHub ingest. We have the particular plugin loaded for each one of the data sources that we need, and I have my recipes here. So we'll DataHub ingest, we'll point it to the recipe. The recipe has all the information it needs, the credentials, the host, the port, and it has the sink or where DataHub is running, it will ingest the metadata. So it will pull the metadata from that source and it will push it into DataHub. And we go back into DataHub, we should see metadata about that data source, which we've pulled in from the data source and pushed into DataHub. I'll show you the DataHub plugins that I installed. So there's a DataHub check plugins, we can run that. And that should show us all the plugins that have been installed. So if I scroll up here for a moment, we can see a list of all the sources I mentioned. DataHub has about 50 sources, and you can see the ones that are not disabled are the ones I installed. So I've installed Athena, I've installed DBT. We talked about DBT and Athena. Those are two of the data sources we're going to be looking at today. I've installed Glue. We're going to be ingesting from Glue, from Kafka, from MongoDB, from MS SQL, from MySQL, etc. This shows all of the plugins that I've installed. Those are the source plugins. There's also sync plugins. In this case, we're going to be using the DataHub REST API. The sync plugin is automatically installed. And then there's different transformers, which are all automatically installed. So some of the transformers that we're going to be using today, I'll show you as we go through and how we use the transformers. So those are the plugins that are installed, and that's how DataHub knows how to talk to these different data sources. The next thing we want to do is set all of our environment variables. So if you recall when we talked about the recipes, there is environment variables. So in this example, I open the manage Kafka or MSK Kafka. In this case, the list of bootstrap brokers is an environment variable. I'm using SASL Scram, so there's a username and password associated with connecting to this Kafka cluster. Username and password are both environment variables. We'll inject those. And then the DataHub REST endpoint. So I'm going to go ahead and pause the video so that I don't disclose any of my credentials. I'm going to set all those environment variables. In order to get all those environment variables, you can use the ingestion instructions. And if you scroll down, I've defined all the environment variables and they're all listed right here. So starting with the DataHub REST endpoint, my account ID, my region, and then for each one of the data sources, I've organized these. So Athena, Aurora, MySQL, MS SQL, Postgres, Redshift. Hopefully these are intuitive enough for you. So example, I showed you Kafka a moment ago. Go back to Kafka, we have the Kafka brokers, the username and password, for example. For the environment variables are right here. So there's three environment variables for Kafka. We'll set all of those: DBT, MongoDB, Atlas, Snowflake, Google, etc. So I'm going to go ahead and pause the video and set my own environment variables, and then we'll move on and see how we actually ingest data into DataHub. So I went ahead and paused the video for a minute and I set all my environment variables that we discussed. Let me switch back over to iTerm. So I'm back in my terminal. I've executed into the container within the pod, the DataHub API container within the DataHub API pod. So I'm within a container within a pod on Amazon EKS. This is the Docker Hub file that I showed you. So I built the image and I deployed that to Kubernetes. And I've just execed into that. So I'm going to be using this as my environment in order to ingest everything. Use the DataHub command for a minute. You can see that I have the DataHub CLI installed. We have all the different commands we're going to be using. DataHub ingest is the primary command that we're going to be using for this part of the demonstration. One important thing to take note of, let me do a DataHub version. You can see here that I'm running the DataHub CLI version 0.9.5. It's important that the DataHub CLI version that you're running and the version of DataHub that you're running, right? So the Helm chart that we installed DataHub with are the same. If not, you'll get some errors. It may or may not cause problems, but generally speaking, you want to make sure that the CLI version you install is the same as the primary DataHub instances you've installed. So I'm running 0.9.5, which was the latest at the time that I started this video. I believe 0.9.6 is out right now, but for this video, we'll use 0.9.5. So the CLI and the primary installation of DataHub are both the same version. All of the files that were in our GitHub directory are now installed in this container. So I did a git clone. I installed all those files and I've gone into the ingestion subdirectory, into AWS, into the first account, into US East 1. If we list those files, we can see that I have all of my recipes here. So Athena, Aurora, Glue, MSK, RDS, Redshift, etc. So these are all the recipes that we're going to be ingesting today. Let's start off by doing an ingestion just to see how that works. So again, all of the commands are in the ingestion instructions markdown file that's included in the GitHub project. And I'm just going to randomly start with one of these just to take a look and make sure everything's working. So in this case, I'm using the DataHub ingest command. It's an Amazon RDS instance. It's a Microsoft MS SQL database, and it's the ticket database. So we're going to ingest the ticket database and all of its tables and metadata into DataHub. So we'll run that. Remember, I set all my environment variables. So the recipes had environment variables. Those were all expanded when I used the DataHub ingest command. It was able to connect to that database, and it was able to ingest all that metadata, and it pushed all that metadata, or it synced all that metadata to DataHub. So the CLI reached out to the database, it pulled the metadata, and it pushed that into DataHub. So if I go back into DataHub, I would expect to see all the metadata information about the ticket database. And we can just continue on. So let me just grab one more. I'll grab our MoMA Postgres database. So again, DataHub ingest command, Amazon RDS database. It's a PostgreSQL instance, and this happens to be the MoMA database. It's one that I used in a previous demonstration. And we can see how easy it is to ingest metadata. Now, obviously I'm doing all this manual for the demonstration. There's a number of ways to ingest metadata, whether that's pull or push-based metadata. There's a number of different ways to do that. For the sake of the demonstration, I'm just doing it for the command line to show you how it works. Typically, you would use something like Airflow or step functions. You might have a CI/CD tool like Jenkins, some of the AWS tools. You would set this up in a pipeline and you would automate all this. I'm just doing each one of these manually in order to show you how the process works, but of course you would wrap some automation around all of this. So you can see that worked. Now these are pretty quick. They're very small databases. There's not a large number of tables. There's not a large number of schemas that I'm ingesting, so it's going pretty quick. The larger your database, the more complex your database, the greater the number of objects, the greater the number of tables, of schemas, etc., the longer this will take. But generally speaking, it's pretty quick. And also because I'm on AWS, so I'm not reaching out over the internet to AWS, ingesting this metadata and then pushing it back into AWS, into DataHub, because I have my DataHub API container adjacent to DataHub and adjacent in an adjacent VPC to those different data sources for the most part that are on AWS, unlike MongoDB, Atlas, Snowflake, or BigQuery. And those will be pretty quick too. But for the ones on AWS, generally speaking, it runs pretty quick. So I'm going to continue on and ingest the metadata from all of our sources before we take a look at DataHub. And then when we're done with the AWS data sources, I'll move on to the data sources that are not on AWS. So I'm going to run all of these sources, let them run in the background. I'll pause this. It'll take a little bit. When it's all done, we'll take a look at the results. So it looks like everything finished. A few small errors, had to go back and adjust a few things. The only thing to note, I mentioned that Amazon Redshift Serverless is a new service from AWS, relatively new. There are currently some issues with Amazon Redshift Serverless. If you run the recipe for those, you'll run into a couple errors. The table structure for Amazon Redshift Provisioned and Amazon Redshift Serverless are different. So the original plugin was designed for Amazon Redshift Provisioned, not serverless. So there are some errors. The community is working on it. AWS is working on it, to my understanding. But for the most part, everything ran fine. It took a little bit of time. Some of them ran very fast. Some of them are pretty small. Some of them a little bit bigger. I just picked some random data sources that I had in Amazon Athena, for example, or AWS Glue, depending on the size of those, depending on the amount of underlying data that it had to extract metadata from. Took a varying amount of time, but relatively speaking, pretty quick for those sources. Let me switch back over to DataHub for a minute. So I'm in DataHub. You can see that I have about 1,200 data sets. I also have the glossary terms. We'll talk about the glossary terms in a minute. We can run the DataHub ingest to ingest our glossary the same way. But you can see that I've ingested those data sources. Now, we're going to talk about dbt, Mongo, and Snowflake and some of those third-party ones in a moment. But we can see that Athena, Redshift, PostgreSQL, this is RDS and Aurora, MySQL, which was RDS, Amazon S3, Kafka, which was MSK, those have all imported correctly. We're going to talk about DataHub and some of the features of it after I finish the ingestion, but if we just go to Explore All for a minute here, we'll just make sure that we have everything. So let's just go into Postgres for a minute, PostgreSQL. We can see that we have our ticket database, our Pagilla database, so those are the two databases. The MoMA database, that's the third database. So two of these came from Amazon RDS. One of those came from Aurora. So all of that's worked. You can see here that we have our account number, and this is where we can change account number. So I ingested everything under this fake account number 1112223334444. I could have gone back. I could run these ingestions. We could switch that account if we had different recipes for different accounts. You would just change that environment variable. If they weren't all in US East 1, we could just go ahead and change the AWS region environment variable. And then when we ran our recipe, it would inject those environment variables into the recipe as the DataHub ingestion command ran. So those are all of our AWS resources. Before we talk about some of the features of DataHub and we explore the UI here, let me finish my ingestion. So I'm going to do MongoDB Atlas, which is a SaaS provider that I've set up on AWS, Google BigQuery, which is running on Google Cloud, Snowflake, which is running on AWS. That's one of my other SaaS providers. And I'll also do DBT. So I'm going to finish by ingesting that metadata, and then we'll take a look at the DataHub UI and how we can work with all that. So I'll switch back over here. I switched directories. So for each one of my non-AWS data source, I have a second directory, but the process is exactly the same. So I use the DataHub ingest command, and it's simply a different data source. As long as I have the proper networking and security and the proper credentials, there's no reason you can't ingest a data source from any provider. So in this case, I'm on AWS, I'm in EKS, I'm in a container, and I'm ingesting metadata from my Google BigQuery account. So that worked. Again, it's a very small data warehouse. It's a very small database that I ingested. So I'm going to go ahead and do the same for my other sources that are not on AWS. And then when we're all done, I'll unpause the video and we'll take a look at the results in DataHub. So I went ahead and ingested Google BigQuery, Snowflake, and MongoDB Atlas into DataHub. I also ingested my DBT project into DataHub. Again, all of the commands are in the ingestion instructions. So now I have all of my AWS metadata sources as well as all of my non-AWS metadata sources cataloged in DataHub. The last thing we want to do is ingest our business glossary, and we'll take a look at the business glossary in DataHub, but first we need to ingest that into DataHub. So let me switch into that directory. So there's a business glossary directory, and if we go back to PyCharm for a minute, we have the business glossary here. There's two files. The first file is the actual glossary, and I've created a very simple glossary. So I've looked at classification of different types of data: sensitive, confidential, highly confidential, personal information. And I've mapped that to different fields and some of the different metadata that we've imported. And we'll take a look at that in DataHub. But again, the glossary is in the first file, and then the actual file that we're going to ingest from that has the coordinates or the path to the glossary is in the second file. And this is the one we're going to ingest. All of the commands, again, are in the ingestion instruction. So if I go back here, we ran all of our AWS metadata sources. I mentioned the Redshift serverless issue. There is an issue with this last file. The file is included, but it will error out right now until they fix that. And then I ingested my non-AWS metadata sources. So Google, Snowflake, MongoDB Atlas, and DBT. And the last thing we want to do is this command right here. So we're going to ingest our business glossary into DataHub. So let me switch back over. I'm in this directory. Just take a look and make sure we have our files. And we do, we have both of those. So let me run this command. So we're done ingesting our business glossary. That took less than a second. Again, it's a pretty small glossary. So now we've ingested all the metadata that we need to ingest into DataHub for our demo. So we've ingested all of our metadata sources that were on AWS, all of our non-AWS metadata sources, and our business glossary. We're able to use the DataHub ingest command to do all of that based on the recipes that we created. I mentioned some Python files. So there's a couple different ways to ingest data into DataHub. Using the DataHub ingest with the recipe is the way that we used. I also have some examples of Python files. So we could also execute a Python script. So just like our recipes, let me open one of the Athena recipes. You remember we had the source, we had a transform, and then we had our sink or our destination. I also have the equivalent Python script for that. So you can see here, I've set the environment variables. I've set the variables within the Python script using the environment variables, the same environment variables that I set for our recipes that were expanded when we use the DataHub ingest command. And we can do the same thing, and we create what's called a pipeline. Has all the same fields that we saw in the YAML file, and we can run that just like a Python script. So again, this particular file is using the environment variables that are set in the environment, pulling those into the Python script. The other way that we could do that, and probably the more AWS way to do that, is to use the AWS parameter store, or even better, AWS or Amazon Secrets Manager. So in this case, this is my RDS Postgres ticket database that I wanted to ingest. We ingested this using the recipe, the YAML-based recipe. I could also use Python and execute a Python script. And again, we're creating a pipeline just like we did before. So this looks just like the first Python file. The only difference is I have a method at the end, and I use that method to go out to the AWS parameter store, and I pull in parameters. So I've already set up some parameters in a parameter store. You could also use Secrets Manager, and for the username and password, I would definitely recommend Secrets Manager. But for things like the host and port, some non-sensitive information, you could also use parameter store. So instead of setting environment variables, I can use Python. I can put my parameters or my secrets into native AWS services like parameter store or secrets manager, and then I can call those from Python. So I don't even need to set my environment variables and risk potentially exposing my credentials for my databases, for example. I can securely set all those in the appropriate AWS services. And then instead of using a YAML-based recipe, I can use the equivalent Python script, and I can use parameter store or secrets manager to call those parameters, inject those into the script, and run the exact same commands that I ran with the YAML-based recipe using the pipeline method that's outlined here. So either method works. There's also other methods. You may prefer to write YAML, you may prefer to write Python, you may prefer to use environment variables and inject those into the environment, or you may prefer to reach out to services like parameter store or secrets manager in order to pull in the credentials that you need to run the recipes. So those are the two Python files that are in here. Now that we've ingested all the metadata into DataHub, we'll take a look at DataHub's front-end UI. As a data consumer, a primary use case for DataHub's UI is to efficiently identify the appropriate data sources based on the metadata in the data catalog. Using DataHub's advanced search capabilities, users can quickly search for and find data source related items like databases, tables, views, pipelines, and so forth. The UI has a huge number of features. I'm only going to highlight a few of the features in this demonstration as it relates to the sources which we ingested. Let me switch over to the front-end UI. So I'm in the main page or the home page of DataHub's front-end UI, and we see a couple ways in which we can search for metadata from the home page. We could type in a search. We could click on try searching for if we want to see how that works. We could explore all, which I'll do in a moment. As we scroll down, we also see we have tiles. So we have data sets, pipelines, and glossaries. I can click on any one of these tiles to quickly drill into those data elements or data items. I can click on the platform, so I could find all of the items related to the different platforms that we ingested. Glue, Athena, Redshift, dbt, Amazon RDS and Amazon Aurora, Google BigQuery, Snowflake, etc. We could click on any one of these tiles to quickly drill into just that platform's assets or items. We also see recently viewed items. We also see recently edited items. We see most popular items. And we also see top tags and top glossary items. And we're going to talk about tags and glossary items in a minute. So those are some ways from the front page or the home page that we can quickly start searching our metadata that we've ingested. So let's start by clicking on one of the tiles. Let's click on datasets. So when I clicked on datasets, we're now presented with 4 different environments. And we can see for each one of these environments, the datasets which are associated with each one of those environments. So I have applied these environments to our recipes. Let's switch back to the GitHub project for a minute, and I'll show you how I did that. Let's go into the Postgres MoMA database recipe, for example, and we can see here the environment tag of dev. So DataHub provides a enumerated list of environments which you can use. Make sure to read the documentation to pick one that's part of the list, or you'll get an error when you try to do the ingestion. So in this case, I've done dev. I also applied the prod, test, and UAT environment tags to some of the other recipes and ingested those just to show you the difference. So again, we were out at the main page. I clicked on the datasets tile to quickly drill down to just view the datasets versus other types of assets. And then I can drill into any one of the environments. So let's go into the dev environment. And once I go into the dev environment, I see the different ingestion platforms. So again, Glue, Athena, dbt, Postgres, Mongo, Kafka, etc. I can continue to drill in this way. So again, this is just one way to search for metadata by drilling down with finer and finer level of grain of detail. So let's go into Glue. And now I'm presented with in this case, since it's AWS Glue and these are Glue data catalogs or Glue jobs, and I've picked data sets specifically. These will all be AWS Glue data catalogs. So I see all the AWS Glue data catalogs that I ingested. Let's click on one of those AWS Glue data catalogs. And again, these are Hive compatible meta stores, not to be confused with DataHub, which is a data catalog. But these are Hive compatible meta stores. They're databases with tables, and those tables contain metadata about underlying information, usually in Amazon S3. So I've clicked on the dev environment. I've clicked on the Glue platform. I've clicked on the ticket_demo database, and I see a list of the tables in that database. If I went into the AWS Glue console and I clicked on the ticket_demo Hive compatible meta store or data catalog in AWS Glue, I would see all these tables. We can open these tables up by clicking on them, and we can see additional information. So in this case, I can see all of the columns that were part of that table. I can see whether or not they're nullable, and I can see the primitive type. So numbers, strings, dates, booleans, etc. So some basic information about that. Let's go back up to the database level. So we see all those tables again. Let's talk about tags next. So you can see underneath each one of these tables, I have a few tags, AWS, US East 1. Let's switch back over to our recipes for a minute. And let's take a look at the RDS Postgres MoMA database since we already have that open. If we look down under transformers, remember that I talked about adding tags earlier when we did our ingestion. So I'm using the transformer type of simple add datasets tags. In this case, we've added the AWS tag for the cloud provider platform, the name of the service, Amazon RDS for Postgres. I added in the account ID, which was an environment variable, the AWS region, which was another environment variable. All of those tags will show up here. And as we look at some other examples, we'll see more tags. So this is a fairly simple example of 2 tags. Let me go back into the same table for a minute. And you can see here that we also have an owner associated with it. And in this case, it's data engineering. So let me click on data engineering. Now I'm viewing all of the items that are associated with the data engineering owner. Again, if we switch back to our recipe, and I'll continue with the same recipe here, and we scroll down our transformers, and in this case, we have the owner of database administrator. So tags are one form of metadata that we can enhance our data sources with, and owners are another. So we can apply tags and we can apply owners, and we can search on either tags or owners, or we can combine those to create advanced searches. Let me go back out to the main page for a minute, to the main homepage of DataHub. And let's use the Explore All option this time. Instead of clicking on one of the tiles, I'll click on Explore All. And this brings up a different interface. We can see here that all of the search criteria are down the left-hand side. So I could choose to click on one or more types. I could click on the platform. We can see all the platforms from the different platforms which we ingested from. I could use a tag. We can see all the tags that we ingested. AWS, US East 1, so the region. Amazon Athena, so the service tags. We see some other accounts here. So we see a different account, 333, 444, etc. versus 111. We see DBT was another tag. We see Snowflake that we tag things with. So all of the tags that we used here should show up here as a tag that we can search on. So we can click on any one of these, for example, Snowflake, and we should see all of the items associated with the Snowflake tag. And in fact, that's what we see. If I want to go back out to Explore All, let me just uncheck that. And we're back out, and now we see the rest of the tags. Now note when I clicked on Snowflake, it also showed me the additional tags which applied to Snowflake. So in this case, with Snowflake, all of my Snowflake assets, it looks like, were tagged with US East 2. So I could drill down farther by clicking on that. I could click on owner. So in this case, they're all the same, but you can imagine if we had different owners for different, in this case, Snowflake data warehouses or Snowflake databases, I might see a list of different owners here. If I had multiple Snowflake accounts, I might see different regions. If I had Snowflake installed on multiple cloud service providers, I might see multiple cloud service providers here, etc. So this is a relatively simple example, but you can start seeing the power of using the platform with the types, with the tags, to quickly drill in and find the type of resources, the type of assets that you're looking for. We can also click on owner too. So now I'm looking at Snowflake, all of the Snowflake instances in US East 2, and that are owned by the data warehouse administrators. So pretty powerful. Let's click off on those. Let's dig into one of these assets and see what we can see about the particular item itself in DataHub. So I'm going to do a search on a particular asset that has some additional information on it. So we're going to be looking at a particular table, a fact table, revenue. So fact_revenue. And this is in an Amazon Redshift database, ticket_rev. So let's search for that. And we see one search result come up. We'll click on that. Here it is. Now in this case, I've applied some additional metadata to this, and I prefer to apply as much metadata upstream as possible. So in this case, if we switch back over to our GitHub project for a minute, there's a file, Redshift schema comments. And with Redshift in particular and some other SQL-based data sources, you can apply comments both on the table. So we see here comment on table, and I've applied a comment or a description to that table. And then I've also applied a comment to each column, so comment on column. So for every column in this table, actually 2 tables I applied it to, I put a description on a table and a description on each column. So let's switch back to the DataHub UI, and we're in the fact table revenue, which is a Redshift, again, Redshift database that I talked about. And we can see here that under documentation, we see that description of the table. So this is a table description that was here. And if we go back to schema, we can see that each field or each column also has a description. And again, I applied that upstream on the Redshift database. The reason I did that is, imagine if we lost DataHub, if some of the backend storage nodes crashed, that's okay. All we have to do is re-ingest the data. I'm not adding data here. Now, as an administrator, I can add links, I can add additional owners, I could add additional tags, I can apply additional glossary terms. We'll talk about the business glossary in a minute. I can do all of that, but now that's only going to exist in DataHub. In my personal opinion, if we lose DataHub, I'm going to lose all that, so I prefer not to do that. I try and add as much metadata to the source as possible. So in this case, I've applied all of this additional metadata directly to the Redshift database table and columns. So imagine as a data consumer, you found this table, you think this is the right table, but you're not sure. You can go into the documentation and read a brief description about the table that might answer whether or not it is the right table. Let's imagine this is the right table. Now you want to understand a little bit more about the table, the columns, the schema. And you can do that. I can see the different column names. I can see the type of column it is. I can see whether it's nullable, whether it's a primary key. And I can also get a description. So someone has taken the time as a data owner to add all this metadata information. As a data consumer using DataHub, I can find all this information out about this data source. So pretty powerful. So that was table and column level descriptions, or column and table level metadata. Let's talk about visual lineage next, another feature of DataHub. So I'm going to search on another item here that I know has some good data lineage, some visual lineage that we can take a look at. So you notice we got a few results here. The first result is for a DBT project. And the DBT project builds a database in DataHub. It builds all the data models for a demo database in the ticket underscore DBT schema. And in this case, the sales facts table. We also see that same facts sales table below, and that's because our Redshift recipe also crawled the same database. So the DBT project created all those data models in Redshift. We crawled the DBT project, we got results. We also crawled the Redshift database, so we got the same results back. I'm going to go ahead and click on the DBT result here for that facts table. So we're in the facts sales table. We can see the schema again. We can see the different column names, the different field names. We can see the type of column it is. But what we're most interested in is lineage. So let's go over to lineage and let's go to visual lineage. This is one of the great features of DataHub. So not only can I get lineage or visual lineage about DBT projects, I can get lineage, and in some cases visual lineage, depending on the relationship between the items that I catalog in that particular data source with any type of data source, right? Whether that's an Aurora database, an RDS database, if that's AWS Glue between a job and a data catalog and a table, if that's Athena, if that's Redshift. So no matter what the data source is, I can see the visual relationship between those different items in that data source. So DBT is a fantastic tool. We can get the same visual lineage in that tool, but I can also import or ingest that metadata from that DBT project into DataHub and view it alongside visual lineage for many other types of data sources. So we can see a visual lineage here on the fact table. So we can see upstream from that are different staging tables and intermediate tables. So in DBT, generally we have staging tables, intermediate tables, and marts. We also have analysis. And we also have, in this case, external tables. So if you're using Amazon Redshift Spectrum, which is the lakehouse architecture approach on AWS. So we have external tables. That data is sitting in Amazon S3. It's been cataloged using AWS Glue. So we have an AWS Glue data catalog or a Hive compatible metastore that contains information about that underlying table. That table is external to Redshift, so an external table in Redshift. And we can see that here. So if we click on some of this upstream lineage, And I'll just open a few of these. We could keep going indefinitely here. If we start on the left-hand side, let's see if we can zoom in on this a little bit. So if we start on the left-hand side, this user table, this user data set is actually an external data set that's sitting in Amazon S3. It's been cataloged in AWS Glue. And that is related to the staging tables. In this case, we see the staging ticket users table. So that's a staging, in this case, it's actually a staging view. So we can catalog views or tables, in this case, the staging view. And that's also related then to intermediate tables or other staging tables, and eventually to a fact table or a mart or a fact view, depending on how you set up your DBT project. So this is visual lineage, gives you a lot of information. You can see how different items are related, or different database objects, depending on your data source, are related to each other using visual lineage. Let's take a look at one more here. And we see our item here. So let's click on that. We'll go to lineage. We see both upstream and downstream elements that are associated with this item. We can go over to visual lineage, and we see a similar view. Next, let's look at some of the administrative functions that I have available to me. We'll go to ingestion. And we see here in the sources tab all of the sources which we ingested from. So we have Kafka or managed Kafka, MSK in this case. We have Amazon Athena. We have Amazon Redshift. We have Postgres, so Amazon Aurora, and Amazon RDS for Postgres, MySQL, etc. So we can see all those. We can also see that we use the CLI to ingest these. So we have a couple different methods to ingest metadata. In this case, we can see these are all labeled with the CLI. Under execution count, I can see the number of times that I ran that particular recipe. In this case, they're all through the CLI, executed a recipe, and we can see the number of times that it was executed. So for example, with MS SQL Server, we can see that we successfully executed that recipe 8 times. If we scroll down a little bit, let's see if we can see a failure. So we see here that BigQuery failed the last time. So we had 3 successful ingestions using the BigQuery recipe, and the last time it failed. So I had an error. I changed the database that I was ingesting from, and I had an error there. I wasn't able to connect, so it failed. We could take a look at the details if we want to see why it failed and try and troubleshoot that. So this is a good way to see all the jobs that you've run to see if you've had any failures and try and troubleshoot those failures here. Next, we'll look at the business glossary. So I'm going to go under Govern Glossary, and we can see our business glossary. If you remember in our GitHub project, I'll go back to PyCharm, we had a business glossary. Let me open that file up. We can see that we had 2 what are referred to as nodes. We had the classification node and the personal information node. And under those, we had several terms. So under classification, we had sensitive, confidential, highly confidential. And then under personal information, we had things like your name, your date of birth, your social security number, your passport ID number, and your driver's license number. If we go back over to the DataHub front-end UI in the business glossary, we can see those same elements here. So let me tip these down. So classification and personal information are what are referred to as term groups. And under each one of those term groups, we have multiple glossary terms: confidential, highly confidential, sensitive, etc. So let me switch back over to the GitHub project for a minute, and let's open up the Athena Cynthia recipe. So we ingested a database called Cynthia Patient Big Data. And in this particular database, which has synthetic patient data, a couple of tables had a column called patient, or contained the word patient. So what I've done in my transformers is I said that anytime a particular element, or in this case, a particular table, has a column with the word patient in it, I want to apply the sensitive classification to it. And that's going to be applied to the table. So if we go back over here, I would expect when I click on sensitive that I'm going to see items, in this case tables, in that data catalog that have the sensitive glossary term applied to it because one of the columns contained the word patient. So let's see if that worked. So we'll go to sensitive, and we'll go to related entities, and we do see some tables. So I see allergies, care plans, conditions, encounters, immunizations, etc. So it looks like that worked. Let's drill into one of those. So we'll go into allergies. And in fact, we do see a column called patient. So because there was a column called patient, and we had a transformer rule of pattern add dataset terms, and we created a rule, so based on the word patient in the column, we added the classification of sensitive to that element or that table. And that's what we see here. So if we go back out, and we see a list of those. We see that sensitive has been applied to every one of the tables where there was a column with the word patient or the name of the column or field was patient. So that worked. Let's go into users and groups now. So let me click on the gear icon. We'll go over here to users and groups and permissions. You can see here that I've set up 3 users. So Susan Jones, who's a reader, Shiva Krishna, who's an editor, and Gary Stafford, that's me, who's an administrator. So I've been logged in as Gary Stafford the whole time. We can see my profile here. Let me click on my profile for a minute. And we'll bring up my profile. So it has a picture of me, it has my name, it has a group that I'm associated with, my email, my Slack address, my telephone number, and what group I'm associated with. Let's go back over to users and groups for a minute. So that's a profile. So we have 3 users set up, 1 reader, 1 editor, and 1 administrator. We also have 3 groups set up, and you associate users with groups. And in this case, I only have 3 users and I have 3 groups. So I've associated one of those users with each one of these 3 groups. So I set up 3 arbitrary groups: DataHub engineers, DataHub consumers, and DataHub administrators. And I assign one of the users to each one of these groups. If we go back to users for a minute, we see that these groups have particular permissions applied to them. So we can see we have an admin, an editor, and a reader, and it describes what those are. And we can see the users that are assigned. In this case, I only have 3 users, so I assign 1 to each one. But if you create additional users, you could decide which role to apply those to, and then those roles have policies associated with it. I'm not going to get too deep into this. You can see that there's fairly fine-grained policies that can be applied to those roles. In most cases, the users of the DataHub front-end UI are going to be readers. So these readers are data consumers who log into DataHub, and they're searching for particular data assets that they're going to use to perform analytics, to build dashboards, or to build reports. The last thing I want to show you before we end our demonstration is analytics. So DataHub provides some basic metrics about the usage of DataHub. We can see that here by clicking on analytics. So I can see the different types of assets that have been ingested into DataHub, the different platforms, etc. I can see the different entity types, the different entities per term, per environment, per platform. And I can also get usage analytics. So the weekly active users, the searches, the number of searches since last week, the top searches, etc. Now, I just stood up this Amazon EKS cluster a couple days ago. I just installed a fresh copy of DataHub for this demonstration and just ingested everything. So there's not a lot of history here, but you can get a kind of a basic idea of the type of stats that DataHub will track for you, and you can see through the DataHub UI. So that's the end of our demonstration. I hope you enjoyed it. The goal of this demonstration was to show you how easy it is to use DataHub on AWS. Using DataHub on AWS, we can ingest a number of data sources on the AWS platform, as well as other cloud service providers' platforms, and including on-prem. So if you have data sources on-prem, you can also ingest those into DataHub running on AWS, and you can ingest data sources from your SaaS partners. So we looked at Snowflake and MongoDB Atlas in particular. We're able to ingest all those data sources into DataHub, and we can see all of those through a single pane of glass. So we can see all those different data sources from AWS, from other cloud service providers, from on-prem, and from other SaaS partners in a single pane of glass in a single data catalog using DataHub. Thank you for your time today. If you enjoyed this demo, please subscribe to my YouTube channel for future videos. Thank you.